Hello, today I will present to you Seki Takakazu, and I'm going to go more in depth of his determinant discovery. I'm going to start off by giving you a historical and geographical context. But first off, I'm going to tell you that Seki Takakazu is also called Seki Kowa in his writings, so you can use both names when you search for him. He was born in 1640, in Fujioka, Japan, and died on October 24th, 1708 in Edo, which is now known as Tokyo today. So here is Fujioka on the map. It's in eastern Japan, and Tokyo is also in eastern Japan, but it's a little bit south of Fujioka, so he moved during his life to Tokyo, where he ended up dying. Japan closed itself from the world for 300 years, starting in 1616 and ending in the 1900s. During that time, mathematicians could not exchange or get knowledge from foreign countries. So the mathematicians from that era grew up in a particular way which obligated them to inspire themselves within Japan, so only inspiring them by other Japanese mathematicians. For example, Isaac Newton, born in 1643 and died in 1717, and Seki Takakazu, born in 1640 and died in 1708, so they lived basically in the same era but could not exchange knowledge between one another. Very little is known about his life and intellectual information, since the Japanese culture was and is primarily based on secrecy. He was the second son of Nagakira Yoshiyama, a samurai that unfortunately died during war. He was given to adoption at age 5 and was adopted at age 6 by Seki Gorozamen, a nobleman. He was known as Japan's greatest mathematician, but he is sadly unknown outside of Japan. Seki's early education is again unknown. But what we know is that he was greatly inspired by Jusi Shiji, Yang Hui, and Cheng Dahui, three Japanese mathematicians from the 13th century through the 15th century. He based himself mostly on their writings and theories. Seki's most important research was in algebra, more specifically the determinants. Seki Takakazu has many mathematical ideas, but I'm only going to go over three. Well, basically the three that I find are the most important and relevant. So first off is the value of pi. He was able to calculate the value of pi to the 11th decimal using his polygon theory. So basically he took a circle and he divided it with polygons within. And in order to calculate the value of pi to the 11th decimal, he used 131 and 72,000 polygons in his circle. So basically, the more polygons there are, the closer the approximation to pi will be. So for example, here I have a chart, and the last line is with 32,768 polygons, and the approximation to pi is pretty decent. But when you look at the approximation with 8 polygons only, the approximation is very poor. Next up, Seki discovered the Bernoulli's number. So basically, he could have called him his name, but Jacob Bernoulli published it later on. These numbers are crucial in finding the sums of powers of the integers in the summations. So his final most important discovery has been determinants. So it's been his main contribution to algebra, and probably his only contribution to algebra. It is known that he introduced algebraic notation, so invented determinants, to solve systems of linear equations around the 1686. So the determinant, by definition, is a value associated with a square matrix. So now I'm going to explain to you what a determinant is, or how to calculate the determinant based on what Seki Takakazu explained to us. So first of all, when you have a 2x2 matrix, what you do is you simply multiply A times D minus B times C, and that gives you your determinant. Now when you have a 3x3 matrix, you have on the first row, for example, in this example, you have ABC, second row DEF, third row GHI. Each of these letters has a sign attributed to it. So A is plus, B minus, C plus, D minus, E plus, F minus, G plus, H minus, and I plus. So there's a chronological sequence to this. And what you do is you multiply A by the determinant of the 2x2 matrix that is not A's row or column. So for example, if you have A, you block off A's row and A's column, so you would block off B, C, and D and G, and A would be your number before your 2 by 2 parenthesis, so you would multiply E times I minus F times H, and that would be your determinant for that part of the 3 by 3, and you would repeat this process 3 times with A, B, and C. So the formula just below it explains to you basically what you have to do. And the same pattern goes for larger matrices, so basically 4 by 4, 5 by 5 would be the same exact thing. So that's the end for my presentation on Seki Takakazu, so thanks for watching and listening.